Hey, this is Kylie. Doing another physics problem. This is one I had out of my book, and I thought it was interesting. It was a good one to do because it had a lot of different free body diagrams. So I'm gonna go through that, and then there's a little bit of algebra at the end too. So you're gonna have to bear with that. So the question is that you have these three blocks, and they're all connected by this cable, and the question is, it wants to know what what the coefficient of friction between the coefficient of kinetic friction between the block 2 and the table, which is this block right here, and it wants to know what the coefficient of friction is between this table and the block. It gives us an acceleration of 0.5 meters per second, and then it gives us the masses, which are just the mass for block 1 is m. The mass for block 2 is 2m. So twice. So this block is twice as this block. This block is twice as heavy as this block. So 2 is twice as heavy as 1, and 3 is also twice as heavy as 1. So it's 2m. So we have m, 2m, and 2m for our various masses for blocks. So those are our given. So let's go ahead and start doing up our free body diagrams. So I'm going to move this out of the way. So we're just going to have to kind of remember what that looked like. So for block 1, let's see if I get this set up right. So for block 1, we do a little free body diagram. We have just a cable coming out of the top of the box. We're going to name that T1. And then we have the force of gravity, which is capital mg, because that's our mass. M1 equals capital M. Okay. So let's go ahead and write out our net force equation here. So we have, oh wait, hold on. Let's go ahead and do the rest of the free body ones first, and then we'll kind of have a better idea how we want to set this up. Okay, so for block 2, we have force connecting to the cable connecting to block 2, and we have the cable connecting to block 1, and then we have our normal force, and then we have our gravity in this one too, which is going to be 2mg. Our mass on this one is 2m. Alright, you can plug these in after. I'm just throwing them in right now to kind of help me out, figure out where I'm at in this one. So then you have block 3. Block 3 is a lot like block 1. It's just going to have T1 on the top, and then also has a mass of 2m, so it's going to have 2mg pulling down the bottom. So now I'm gonna set up my coordinate system. The way it's usually helpful for me to look at these and kind of gives me an answer that seems logical is that kind of like to follow. I kind of like to follow the cable with all my stuff. So kind of like I'd have it going in the positive direction here, and then on 2 I would have it going positive and positive. And since the cable's going this way, I kind of want to just make this one positive going down here too. It doesn't really matter how you set these up as long as you stay consistent with how you do your coordinate system. So we're gonna go ahead and put that in here, and then I can start setting up my equations. So I have positive is up. Put this over here. Alright. Up is positive here and to the right. And then this one I'm going to have positive going down like I said. Okay. Alright. So now let's go ahead and do up our equations. So I have T is pulling in a positive direction, so that's going to be positive. Gravity's pulling in the negative direction, so I'm going to subtract that. And then all of that equals big M, because that's our mass, times acceleration. Okay? And that's all I got for this one. So, oh, here, and I forgot a force on 2. You're also going to have your frictional force, right? And I'm assuming it's pulling to the right because this block's heavier than this, than this block. So I'm going to go ahead and try my kinetic friction here. And I'm just going to put that like that. We're going to put a little K on that. Okay? It's really just kind of running along this same line. I mean, that would be a good way to look at it, I think. It would be like I have the tension pulling this way, and then also friction is creating a force going to the left. So those, T1 and my frictional force will both be pulling against T2, which is going in the positive direction. So I got T2 minus T1 all minus frictional force equals 2 MA. Okay. So the reason I needed these is because I'm going to need an equation for my frictional force, which is going to be here. I don't know if I should write the give you the our standard formula here would be coefficient of friction times the normal force. Alright? So, and our normal force here, we'll have an equation for that too. So the normal force is pulling up, and this is pulling down. And we're going to say that it's stationary because it's not going through the table. So we're going to say normal force minus gravity equals 0. Alright, so these are all equations for block 2. Alright, so now for block 3, it's going to be pretty similar to this one. Let me put the little subscript on that. So T2 now is pulling in the negative direction because I said that down is the positive direction. So we're going to have, I'm kind of getting stuck here in the corner. Put little lines in here. And so the gravity is pulling in the positive direction. T1 is, or T2, pulling against that, and then ran out of room. So I'll put that over here. Equals 2 MA. Okay, so those are all my equations, and now all I have to do is stick them all together and solve. So what happens, let me just switch out sheets here. I'm going to have to move this